Is there other intelligent life in the universe? Now, I know some of you may wake up in the morning and read the news headlines and wonder if there's intelligent life here. But let's go back to that question. What lies beyond our solar system? What lies beyond our galaxy? Philosophers and scientists have been trying to come up with answers to those questions for ages. Some Hollywood movie producers have also tried that with mixed results. But we are now getting massive quantities of data from the outer reaches of the galaxy to be able to, for the first time, answer some of these questions. And as we contemplate the cosmic realities, we also can go to the other extreme of the scale, from the interstellar scale to the microscopic and cellular scale inside our bodies. And there are many mysteries to be solved there as well. For example, what causes disease? How do we halt the aging process? Without dying, that is. But just slow it down. Can aging be reversed? There are lots of examples on the human health side that I want to get into a little bit more detail there. And frankly, we could have chosen any number of subjects to talk about AI, but we'll just spend a few more minutes on the human health side. So in order to talk about some of the data and what lies ahead, I wanted to get you to start thinking about the massive exponential growth in data we are all experiencing around us. So I'll use three quick examples: astronomy, I'll talk about human health through genomics, and then we'll talk about YouTube. It's always fun to talk about YouTube. There is a new radio telescope in Australia that is capturing data at the rate of 7.5 terabytes a second. And by 2025, that rate is expected to go up 100-fold. Now, if you look at YouTube, YouTube is capturing data through video uploads, 400 hours of video uploaded every minute. And of course, you go to high density, high fidelity, 4K, lots more data gets uploaded every day, every week, every month. But when you talk about real tough challenges like human health and human genomics, the amount of data we are talking about is just mind-boggling. So in order to show you that data, I would have to really redraw that scale for you. And we are talking about exabytes of data. 1 exabyte is 1 billion gigabytes. And so the scale of data that we need in order to solve some of the most pressing challenges that humanity faces with the help of AI, with the help of machine learning, because this is not really a problem that human beings can solve without these tools. The amount of data that we need to analyze is just staggering. So diving a little bit more into the world of medicine, this is really a big data problem, as I mentioned earlier. And as we dive into genomics, this is where a lot of the secrets that make us who we are, that make us different from each other, are really hidden. And these are the secret codes that we really need to crack. Now, if you think about some of the numbers there, we have 30,000 genes and 3 billion base pairs. In order to analyze and sequence this data, you have to oversample 30 times to take care of a lot of errors that happen in alignment, as well as the sequencing process itself. And that means 5 terabytes of data is needed to properly sequence in detail the genetics of one human being. So you can see how quickly all of this adds up and grows. But the human genes are just the beginning. We all actually have a biome inside our body made up of other organisms, and that's resident in the gut. And indeed, the number of cells in the human body that are human is actually only 1/10 of the total cells in the body. And these 90% of other cells are coming from organisms in your gut that science is just starting to understand. This is what constitutes the microbiome. So, why is this microbiome important? There has been a lot of research in the last few years that has shown that this microbiome interacts with our genes and creates conditions of health or disease. And through the use of some primitive AI tools and some early machine learning, scientists have tried to capture the biome signatures of many people who are healthy and many people who have disease, and they have started to figure out that people who have disease actually have different signature of the organisms in their gut than people who are healthy. And this is a very stunning development in and of itself, because now it is possible to tell not just who is likely to develop disease by sampling the biome, but also find cures for those diseases. And some of these cures have already started to take shape. And as these cures have started to take shape, some new discoveries that are astounding have come to the forefront. For example, in trying to cure a disease, one person's biome was transplanted into another person, and it turned out that the recipient's body mass became very similar to that of the donor. And that is what led to this new discovery that our weight and our body mass is controlled more by these organisms in our gut than by our diet. And this completely changes how we think about things. And this also talks through why 95% of the people who are going on a diet end up failing. Because when people go on a diet, their metabolism actually slows down, and the body resists that change in weight. And I thought it was just me. But this is very reassuring. So I have to say that this is just really the start of what science has been able to find. And there are such promising capabilities that will come out of it. And it is really going to revolutionize the world of medicine. Medicine, as we know today, is very, very reactive. We have people who develop symptoms of disease, go to a doctor. The doctor would, try to figure out what these symptoms mean, create a diagnosis. Sometimes it's wrong, sometimes it's right. Takes a few iterations. Go to a pharmacist, pretty much the same type of medicine dispensed out, regardless of the fact that we are all different from each other. And then you go to the pharmacist, and the pharmacist takes an hour to give you 10 pills from a big bottle to a small bottle, and you go home and it doesn't work. Sometimes it works, a lot of experimentation. But all of this is very, very reactive, it is very slow, and it is unfortunately a one-size-fits-all. The future of medicine, you can call it precision medicine, you can call it personalized medicine, is where a lot of that is done very differently. In that, there is a genetic signature that you have, there is a biome signature that you have, there is an interaction between that doctors understand, and based on that, it is possible to tell what diseases you're likely to get even before you get them. Now doctors have been able to see through these studies of the biome that there are changes taking shape inside your gut months and sometimes years before any chronic disease is developed. And that is a very, very long lead time to have in order to try and prevent that disease or to get a head start in curing it. So medicine is going to go from its current state to being very personalized, preventative, and it is going to be a transformational change. But none of that can happen till we get to a point where all of our DNA, our genome has been sequenced, our biome is understood, the interaction is understood, and a lot of learning takes place about how it contributes to human health. So switching gears a bit, I wanted to now talk about another disruption that we are on the doorstep of, which is the 5G revolution. And really, when you talk about cellular networks, to most people, 5G is just another step up from 4G, just like 4G or LTE was from 3G. Well, the reality is that 5G is not just a faster version of 4G or LTE. It is a very transformational technology, and it's starting to get rolled out within the next few months from two of the biggest carriers. And this is incredible. I mean, much lower latency. And imagine having the speed, the broadband speed of a wired connection that you have at home. Imagine having 10, 20, 30 times that speed delivered over the air to devices. I mean, that is just going to transform how we communicate with each other, how we interact, how we get entertained, being able to download HD quality movies in seconds. And furthermore, what 5G enables is a big explosion in endpoints that you can connect to, which means for the first time, we will have true machine-to-machine communication capable networks. And when you have that machine-to-machine communication capability, again, you have created something that really allows for new businesses to be created, new business models to be created, new services to be created, and it gets us to the next level in this AI revolution. And the reason I talk about AI in the context of 5G is because now with this machine-to-machine communication, you're really able to do the inference at the edge. More artificial intelligence capability in devices, not just in the cloud. And that is extremely important to take us to the next level of making AI more pervasive in more devices. So let me give you just a couple of very quick examples. So on the business side, when we look at saving energy costs, that's important to everyone. It's even important to the utilities. Smart metering, very, very pervasive going forward. Machines who are able to call home and request maintenance even before they go down is going to dramatically reduce downtime in factories 75 to 80%. Supply chain tracking for packages in real time will become a reality with these more advanced networks. When we talk about agriculture, making the entire food supply safer, increasing yields on crops using drones and other interconnected devices and sensors. And we talk about mobility. Mobility is already so important to us. But if you think about that future, we are going to now be able to integrate with 5G new capabilities that relate to AR and VR. Now imagine you're looking for a new home or a new apartment, and instead of just looking at a window on the browser of your computer, you are able to actually experience through virtual reality what it is to actually walk through that apartment. It will be actually like being there. There are startups today that are working on visualization of what it will mean for you to look at yourself in the mirror wearing a dress that you're seeing on Amazon or your favorite website. All of that is coming at us at breakneck speed. Now, switching to autonomous driving, I mean, this is really the most profound change to the driving experience in our lifetime. And dramatic progress is being made behind the scenes in the advancement of this technology. Some of these headlines here and there, notwithstanding about challenges that these systems face, and there will be challenges, we are making tremendous progress. And the reason this progress is important is because 1.2 million people die every year around the world in traffic-related accidents, car-related, vehicle-related accidents. And many studies show that when autonomous driving is fully implemented, 90% of these deaths are preventable. And that is one of the most profound ways in which technology can really positively impact human life. Now, when you think about all of this AI training workloads that are running in the cloud and trying to create this improved intelligence, what's important to understand is how much the hardware infrastructure is in play in making this new technology work the way it does. For example, if you look at the amount of memory it takes to run a typical AI server versus a standard server, if you look at our projections for 2021, 7 times more DRAM memory needed in an AI training server compared to a standard server. Double the amount of NAND flash, because this is really the raw material that AI ultimately needs more and more of. And we are very excited at Micron because our portfolio, we believe, and as Sanjay said earlier, is the most complete portfolio for AI in the cloud data center. And it spans the entire hierarchy. We have extremely fast DRAM for low latency accesses to data, including our leadership in graphics DRAM and our upcoming products in high bandwidth memory. On the other end of the scale, we have very, very fast flash technology, the lowest cost flash technology in the industry, the most efficient flash technology in the industry, both SATA SSDs that we have already introduced and upcoming introductions of NVMe SSDs. And then we have 3D crosspoint technology, which offers much higher density of memory and non-volatility to expand the use of memory in these servers, as well as has the option to be used as very, very fast storage, because 3D crosspoint is significantly faster, much lower latency than flash. So it's a really complete portfolio. And if you look at the ecosystem of suppliers out there, there are 6 companies in the world who produce flash, 3 companies who produce DRAM, 2 companies who produce 3D crosspoint, and only 1 company which produces all 3, which is Micron. So that is really an exciting place for us to be. Now, going beyond the data center and going beyond just these generic products, we have a ton of exciting technologies that we are working on, including some software that we are showing to our customers can speed up their capabilities in the storage stack by 5x to 8x in terms of performance improvements. Tremendous improvements in our QLC SSDs, which are actually replacing hard drives at very, very compelling price points. And we were the first company in the world to actually introduce QLC SSD to the market. Now, Micron is a very successful choice for the edge as well. When we talk about automotive, we really have the biggest market share in the automotive business. We are really excited to partner with our automotive customers, especially on their journey towards autonomous driving. And we also have created the world's first 12 gigabit low power DRAM die. And our low power DRAM has the absolute lowest power consumption based on feedback from our customers in the industry, which means longer battery life, better user experience for their customers. So moving on, I really wanted to talk about the choice that we are making internally to deploy AI solutions in our own factories, in our own fabs, both in our front-end manufacturing facilities, which manufacture the wafers, and then in our back-end assembly, packaging, and test facilities. And we have deployed computer vision capabilities. We have deployed advanced acoustic sensing devices. Thermographic images are being constantly assessed, and sophisticated programs analyze these details so as to improve the quality of our products, identify problems in the manufacturing process as early as possible. We are generating 5 terabytes of data a day that we are analyzing just from our manufacturing facilities. And the results have been really, really amazing. We have had faster yields ramping to maturity, output increase from our existing tools and facilities, and dramatic improvements in quality that we are able to offer our customers. Now, all of this comes down to partnering with our customers. And we really wanted to thank all of you for being here today. Also wanted to thank all of our customers for the business with us. And we look forward to really enabling the AI journey and the machine learning capabilities that our customers are deploying. But it goes one step beyond that. We also want to partner with startups in the ecosystem and actually help accelerate the development of AI and machine learning capabilities in the industry. And for that, we are announcing today a $100 million investment focused on venture funds that we will be making into startups that are focused on AI and machine learning capabilities. We will be looking forward to not just investing in companies that are creating this future that we discussed and that other presenters have spoken about, but also bringing the scale and resources of the companies to bear so we can help these companies realize their true vision and the full power of their innovations. Not only with our storage and memory technologies, but we also have some really exciting new memory capabilities that we have had several requests from our startup ecosystem, and we look forward to working with them in those areas. 20% of this amount is going to be focused towards companies which have leadership featuring women or groups which are underrepresented in leadership in technology companies. And that is our ongoing effort as a company to be driving diversity in the technology landscape. So with that, I just wanted to summarize by saying that the trends for exponential growth in data are very much alive. We spoke about a couple of examples very quickly today. You have heard from other speakers, and you'll hear more in the next few sessions about this. And that exponential data growth is requiring a lot of analysis, a lot of from data to insight to intelligence journey. And that means that a lot of the core products that Micron builds are at the nexus of these important secular growth drivers. And we are really excited with where the industry is going. And we look forward to working with our customers and our partners to deliver on the promise of AI. Thank you.